Okay, hopefully you have developed a good understanding of how to write a trig ratio, because today we're going to use these trig ratios to find missing sides and missing angles. So we'll start with this first one here. I have a missing side in this right triangle, and it's wanting me to find side x. The truth is, if I had two sides, I could just use Pythagorean theorem. But since I only have one side, I am going to need to be doing a trig ratio. My first step is always to mark the angle, like I did when I was just stopping at the ratio, and then label things. I label the hypotenuse first as across from the right angle. Opposite is the one that's across from the 53. So once again, opposite is down there, and that means this is adjacent. So now I need to look at what pieces I need. The piece I need is the adjacent, because I know 4 and I'm going to have to use that, and the opposite because that's the x I want to know. Hypotenuse doesn't really help me for this problem, so I'm going to pick a ratio that involves adjacent and opposite. So given the ratios of sine, cosine, and tangent, it is tangent that involves opposite and adjacent. So I'm going to say that tangent of 53, because this time I know my angle. It's a little bit different to have an angle in there, but tangent of 53 degrees is x over 4. And what I have been able to do is use my trig ratio to write an equation. Now, once you have an equation, you can solve for x, and usually your first step is going to be to multiply both sides by whatever's in the denominator. So in this case, to get rid of a divided by 4, I multiply by 4, so I have 4 tan of 53 degrees equals x. Now, the truth is, this is my final answer, 4 tangent of 53, but we probably want that to have some context, so we're going to go over to Desmos to make that happen. And when I'm in Desmos, I'm going to do just 4 and then tan of 53 degrees. And that will get it for you. If you are using a device where you don't have a keyboard, I can do 4. And then I can pull up my keypad, go to functions, and the first thing that pops up usually is trig. If it's all miscellaneous or something else, you can make it go back to trig, and then do tangent, and then 53. It puts a little parentheses in there for you, and it tells you that 4 tangent of 53 is 5.3. Usually we're going to want these to the nearest tenth, and it's important to think if they're reasonable. Well, if one side's 4, it seems reasonable that another side might be 5.3. Now, some of you might have been following along and getting a different answer. It's important when we're dealing with the trig functions to pay attention to our settings. Down at the very bottom of my settings, if I can get my picture out of the way, we have the option of radians or degrees. We haven't learned what radians are yet. We will be talking about those very soon, but degrees is the mode you're going to be needing to use for this right triangle trig. So be sure you have it turned on to degrees. Now, if you have it on degrees, you should have a 5.3. And if you do the testing version, North Carolina test version of Desmos, that's going to always come up with degrees by default. So 5.3 is your your approximation of your answer. Now we can go ahead and do at least one more of these, I'm sure. This one is, we marked the 52 because I only have one side that I know, so I'm going to have to use trig. Label this as hypotenuse. The one across from the 52 is opposite. The one next to the 52 is adjacent. So I'm using opposite and hypotenuse. Opposite because I know it, hypotenuse because it's what I want to know. So the trig function that's based on opposite and hypotenuse is sine. So I have sine of 52 degrees equals 15 over x. In this case, I'm going to multiply both sides by x, and I get x times the sine of 52. You do kind of have an extra step on this one because you're always going to start by multiplying to get rid of that denominator, but in this case, x is not by itself yet. So now to finish getting x by itself, I'm going to have to divide both sides by sine of 52. So I'm going to get 15 divided by sine of 52. This is your final answer, but we can get a decimal approximation with Desmos by doing 15 divided by sine of 52. And once again, the parentheses are optional if you just have a single number argument, and that gives you 19.3, which seems reasonable based on the size of my other leg. The hypotenuse would have to be a little longer.